has to have true and false, but not both. So a mathematical sentence is either true or false. So for example, 3 plus 5 equals to 4, which we know it's incorrect. So therefore it's a false statement. 2x plus 3x is obviously 5x. So therefore this mathematical sentence B is actually true. Negation. Negation simply means that a statement is being negated by, for example, for A, 3 plus 5 does not equal to 4, which is actually true because 3 plus 5 is actually 8. So we add a negation by, normally we add it does not equal to something. Same goes for 2x plus 3x is actually 5x. We know it should equal to 5x, but if you add a negation to it, does not equal to 5x, it changes the statement from true being false. So by doing negation, you can actually change the truth of a sentence. So for example, 3 plus 5 equals to 4 was actually false. By adding negation, it becomes true. Same goes with the sentence in B. 2x plus 3x is 5x was true, but by adding a negation to it, you actually change the true to be false. Compound statements. Compound statements can be formed by combining them in various ways. So the most popular words that we use to combine mathematical statements are and, or, if, then. So for example, 3 plus 5 equals to 4 and 4 plus 5 is larger than 10. So both of these statements, the first one, 3 plus 5 equals to 4, is actually false. And the second statement, 4 plus 5 larger than 10, is also false. So both of them are false. Therefore, the final conclusion is also false. Okay? And for the term or, 3 plus 5 equals to 4 or 4 plus 5 larger than 10. In this case, both of these statements are false. So the final conclusion, they are false. Okay? So for example, the word if and then, if 3 plus 5 equals to 4, which we know is not true, then 4 plus 5 is larger than 10. So this statement, it becomes true. So by adding if and then, also you can change the truth of a statement. So these are some of the related implication symbols which we will use throughout the proofs chapter. Okay. This symbol simply means for all values of x. Okay, and this E, X, E, upside down E, yeah, it means that there exists an X. Okay, and the most popular symbol is this arrow. Okay, arrow which actually represents the implication symbol, and the if symbol, meaning if and only if. So this symbol here represents if and only if. So we will use these symbols again and again in the coming slides. Yeah, so please pay attention to the symbols. For example, there are several ways to actually do a mathematical proof, and it must be supported with logical steps and clear explanation. So every single proof must have an implication which represents a true or false outcome. Yeah. So for example, if x is larger than 5, then 2x is larger than 10. So for this statement, obviously this statement is true because if x is larger than 5, so for example, x is 6. So 2x will be 12. So obviously 12 is larger than 10. Okay, this is true by solving this inequality. So when you solve 2x larger than 10, so definitely your x is larger than 5. So this indicates that x being larger than 5 will actually result in 2x being larger than 10. So therefore, this particular statement 1 is true. The next statement is, if x squared is 25, then x is 5. So if you think of this statement logically, this statement is obviously false, simply because if x squared is 25, then there's a possibility of x being positive 5 and also negative 5. So in order to show that this is false, you simply solve x squared equals to 25, and you will get x being plus minus 5. So therefore, x being 5 is not the only answer for this statement. So therefore, this particular statement is actually false. Okay. So how do we use this implication symbol? Implication statements are often called with if and then. So if and then statements are implication statements, yeah. And how do we actually write them out using the implication symbol? The first example will be actually this. That means if and then can be represented with the implication symbol. So when this implication symbol, you should simply read it out as if x is larger than 5, then 2x is larger than 10. For the second example, is also similar. If x squared equals to 25, then x would be 5. And then you can actually make a conclusion whether it's true or false. So how do we actually find the converse of an implication? So if statement P, then statement Q, right? Then the converse would be written as statement Q, if statement Q, then statement P, because it's the converse. Okay, that's the guide to write converse statement of an implication. So for example, this statement, x being larger than 5, if x is larger than 5, then 2x is larger than 10. And obviously we know this is true because we have explained that in previous slide. Yeah. So the converse of this statement, using this guide of writing the converse statement of an implication, it will simply be, we will need to swap the statements. So statement Q comes first. So therefore, if 2x more than 10, then x will be larger than 5. So you have seen we have actually swapped the position of the statement, right? And this is still true, okay? So therefore, this is how you actually write a converse of a implication statement, yeah? So next statement, the same statement with the previous slide. If x squared is 25, then x equals to 5. So the converse of this statement would be, if x equals to 5, then x squared equals to 25. But writing a converse at times can actually change the truth of the statement. It can be true or false. It can swap the truth of a statement. Yeah, so please pay attention. So why is this true? The second converse statement is actually when x is 5, then definitely x squared is 25. There's no doubt to it, and it has to be true. The first one is false. The statement is false. Statement 2, simply because I've already explained in the previous slide. Yeah. To prove an implication is false, it is often necessary to give a single counterexample. So a counterexample simply means that you give an example that actually proves that a particular implication is false. So you just have to provide an example. So for example, for the second statement, if x squared equals to 25, then x is equals to 5. So this statement is false. So the proof will be, the counterexample here is x equals to negative 5. So this statement is false because the possible x value is also negative 5. Okay, two-way implications or equivalence, yeah. So if P, then Q. And if Q, then P are both true when we can say P is equivalent to Q. So in this case, there's another alternative. P if Q, IFF here means if and only if here. Okay, and you can use this notation, which is if and only if. This represents a notation as I showed in the earlier slide here. Okay, next, in the first example just now, x is larger than 5. then 2x is larger than 10. And this works both ways, and both ways are both true. So therefore, you can conclude the first statement just now can be written as x being larger than 5 if and only if 2x is larger than 10. But you cannot conclude this about the second example, because when you wrote the counter example of the second example, it actually changed from false to true. So we cannot indicate that if and only if for that particular second example. Okay, now we are going to look at how do you actually write a inverse, converse, and contrapositive if you are given a mathematical statement. So this mathematical statement is stated as if triangle ABC is right angle. So we have got two parts to this statement. If triangle ABC is right angled at C, then the second part of it says then C squared equals to A squared plus B squared. So we have two parts to this mathematical statement. That's why it's an implication statement which has if and then. Okay, so now we're going to write the inverse of this statement. Because it's an inverse, so therefore C squared does not equal to A squared plus B squared. So this is the inverse of this statement. The converse is simply C squared equals to A squared plus B squared, then triangle ABC is right angle at C. So what we did, the converse is similar to the previous slide. So we actually just swap the two statements around. We've actually swapped these two statements around in order to create the converse. Okay, in order to create the converse here. Right? And by using of course, the word if and then. Pay attention to the word if and then. So that's how you actually write a converse. A contrapositive here is simply when you actually add negation to the converse statement. So what we did here was you have equal to here in your converse and is right angled. All right. So what happened here is we actually swapped it to, we negate it. C squared does not equal to, and ABC is not right angle. Keyword here is not. So we have actually added negation to the converse and it becomes the contrapositive statement. So if the implication is